right, welcome. We are starting off Unit 8, in which we are working with rational expressions and equations. On Lesson 1, we'll be simply simplifying rational expressions. So what is a rational expression? Well, it's a function that can be written like this. Okay, and our directions say where p of x and q of x are polynomial functions. Pretty much it's a fraction that has variables in both your numerator and your denominator. Okay, putting it in basic terms. But do keep in mind your denominator cannot equal 0, and we will revisit that concept in just a moment. All right, so your basic steps. To simplify a rational expression, you first factor the numerator, factor the denominator, cancel your common factors. So your key words here, people, are factor, factor, cancel. Once again, factor, factor, cancel. Notice cancel was the last word I said. When you see a problem like this, if your first instinct is to cross things off, that is wrong. You need to factor first. Come back to that in a moment. All right, something else I want to point out. It says once factored, identify any values of the variable which would cause the denominator to become 0. These values are where the domain of the rational expression is restricted. So what we're going to do is identify our restricted values, okay? And it tells you hint, set each factor equal to 0 and solve. So pretty much we're saying, okay, go ahead and find your restrictions. Find out what numbers, if you were to plug back into the original problem, would cause you to have a denominator of 0. Because remember, we cannot divide by 0. It's not mathematically possible. It's a big old no-no, so we need to set what those restrictions are. So we'll deal with that towards the end of the problem. So let's take a look. Notice in all three examples, they are just fractions that have variables in the top and the bottom. So once again, our steps are to factor, factor, cancel common factors. I am not just going through and saying, hey, look, x squared is there. No, you cannot do that. Why? Because A, they're not factored yet, and B, this x squared in your numerator is connected to the 2x by an addition sign. This x squared is connected to the -4. If you were to simply evaluate this fraction, if you substituted a number in for x, you would get a value. If I were to cross off the x squareds, it would not be equivalent. So let's just really quickly do that because I want to show you the truth. So let's just say, I don't know, let's plug 3 in for x. I just picked a value. So if I substitute 3 in here, I get 9 plus 6, right, which is 15. Okay, so my numerator would be 15. In my denominator, if I substituted a 3 in, I would get 9 minus 4, which is 5. Okay, and I can reduce that to 3. So the number itself is kind of irrelevant, but what I want to point out is if you thought, oh, hey, x squareds, they can get canceled. Let's see what would happen. I'd have 2 times 3, which is 6, over -4. If I reduce that, I have -3 halves. -3 halves and a +3 are not the same number. I hope we all know that. Those are not the same number. Therefore, these two, the original, and if I just cancel out the x squared, are not equivalent, okay? All right, now, so let's go through and actually do this. And keep this number 3 in mind because I will show you how it's equivalent at the end. So I'm just going to jot that down here. So remember, we plugged 3 in and we actually got 3 as an answer. All right, so anyway, step 1 is factor that numerator. Oh no, factoring. Yes, guys, you have to be able to factor. If you are still struggling with factoring, you need to come see me. All right, so up top, I can pull out a GCF of x, which leaves me with x plus 2. Okay, that is completely factored. There are no more exponents. Nothing else can be done. In my denominator, I can factor that. That is a difference of perfect squares. So x plus 2 and x minus 2. Factor, factor. Now I can cancel because everything is fully factored. So for canceling, I'm looking for common factors in my numerator and my denominator. Are there any? Why, yes, there is right here. My x plus 2's can be canceled out. That leaves me with x over x minus 2. This is mathematically equivalent to the original one. It's just in simplified form. Let's use our value of 3 to check it out. If I substituted 3 in for x, I would get 3 over 3 minus 2, which is 3 over 1, also known as 3, which is what I got when I substituted it in up here. Okay, so I'm showing you that by factoring and canceling, I'm reducing the fraction, guys. Okay, just like when we had a number, if you had 8 over 6, reduce that by factoring. Okay, this ends up being 4 times 2, right? Down here is 3 times 2, so we cancel the common factor of 2, which we know if you just look at it, hey, divide them both by 2. Same thing, I'm reducing a fraction here, but with variables. So I factor, and I cancel. All right, now the last step we need to talk about is those restrictions. So what we're going to do is we're going to go ahead and you can write it out if you want to. If you said each factor in the denominator equal to 0 and solve, we've done this before though. We're literally finding the zeros, okay? So x equals -2 for the first one. Sorry, I'm doing this on my computer so my remote thing can charge. And then this one, if I said equal to 0, I get +2. So for my restrictions, I would say, okay, x cannot be, so I'm going to put an equal sign and put a no through it, 2 or -2. Because those are the two numbers that if you substituted in for x would give you a denominator of 0, which is a big old no-no. So this is my answer. X over x minus 2 with restrictions set at 2 and -2. Those cannot be the actual values. Okay, notice we did the restrictions even for things we canceled. So you do the restrictions of the denominator after you factor it. All right, let's take a look at number 2. Factor, factor, cancel. All right, so in my numerator, I can factor out a GCF of 8y squared, which leaves me with y minus 2. All right, my denominator, I can pull out a 2y, which leaves me with y squared minus y minus 2. Can that be factored farther? Yes, it can. Two numbers that multiply to -2 and add up to -1 will be -2 and +1. Okay, so I've got 8y squared times y minus 2 all over 2y, y minus 2, and y plus 1. Okay, cancel common factors. I can cross off the y minus 2's. Now, the two 8y squared and 2y. 8y squared is not, they're not attached because that's 8 times y times the y minus 2. Okay, and in the denominator, I have 2 times y, etc. So I am allowed to reduce those. I couldn't do it over here, like I can't just cancel the x's because this x is attached by a subtraction. This y is not, it's y times things, so that's fair game. So I can reduce the 8 and the 2 to 4 over 1. And I have 2 y's up top and I have 1 in the bottom. So I can get rid of 1 in the numerator and I can get rid of that y in your denominator. So what am I left with in my numerator? Just the 4y. And in my denominator, I'm left with 1 times y plus 1, which is y plus 1. We do not need to write the times 1. Good. So that's my answer. Now restrictions. Y cannot be +2. Y cannot be a -1. And it can't be 0. Okay, because I have a variable there. So y cannot be 0, -1, +2. All right, let's take a look at number 3. Okay, now in my numerator, notice my x squared term is negative. It's much easier if that x squared term or whatever squared term is positive. So I'm going to go ahead and factor out a negative up there. So I have negative times x squared plus 2x minus 8. In my denominator, I can take out a GCF of 3x, which leaves me with x squared plus 9x minus, oh, sorry, I forgot to divide that by 3. 3x minus 10. All right, both of those can be factored farther. My numerator can factor into x plus 4 times x minus 2. My denominator can factor into x plus 5, x minus 2. Move this box. All right, so if you want, you can set your restrictions now so that you remember to do, to include everything, even the canceled factors, or you can wait till the end. It doesn't matter. But x cannot equal 0 because of that. -5 and +2. All right, answers. Bye. Bye. Factored form. All right, so guys, the main thing is factor your numerator, factor your denominator, set restrictions from the denominator, and cancel your like terms. All right, there are 3 you try problems on the bottom. So why don't you go ahead, pause the video. I'm going to pause as well, and I'm going to go ahead and work through those. So when you hit play again, the answers will reappear. So I really want you to try these on your own. All right, pause that video. All right, go ahead and take a look. One thing I just want to point out is in the last one, there wasn't much to cancel, and that's okay. That's going to happen sometimes. All right, so go ahead and take a look. If you made a mistake, try to figure out where it is. If not, please come on in and ask questions. But that is all. Adios.